third method for solving a system of linear equations is called elimination. This strategy differs from substitution in how the variable is isolated. However, the second part of both strategies is the same. Let's look at an example. Solve the following system of equations by elimination. Verify the solution. The two equations are in different formats. To use the elimination method, we need to rearrange one or both of the equations so they are in the same format. Let's rearrange both equations into general form. Please note that this is a different solution strategy than the one shown in lesson 8.3. Subtract 5y from both sides of the equation and add 38 to both sides of the equation. This equation is now in general form. Subtract 8 from both sides of the equation and add 7x to both sides of the equation. Rearrange the terms so the x term is first and the y term is second. Now both equations are in general form. To use the elimination method, we need one pair of variables to have the same coefficient. The sign can be different, but the number must be the same. We can try to make the x coefficients match by multiplying each equation by a constant, or we can try to make the y coefficients match by multiplying each equation by a constant. Neither looks easier than the other, so we'll work with the y coefficients. The least common multiple of 5 and 6 is 30, so we can multiply each equation by a constant in order to make both y coefficients 30. We can multiply both sides of the first equation by 6. There is now a coefficient of negative 30 on y. We can multiply the second equation by 5. Now there's a coefficient of 30 on y. Now that both equations have the same y coefficient, we can proceed. The signs of the two coefficients are different, so we'll add the equations. This will cause the two terms to reduce. To add the equations, line them up one above the other so the corresponding terms line up. The x terms line up, the y terms line up, the constant terms line up, the equal signs line up, and the zeros line up. Add each set of terms. 12x plus 35x is equal to 47x. Negative 30y plus 30y is equal to 0y. 228 plus a negative 40 is equal to 188. 0 plus 0 is equal to 0. This simplifies to 47x plus 188 is equal to 0. Notice that we've eliminated y from the equation. We can now solve for x. Subtract 188 from both sides of the equation and divide both sides by 47. X equals negative 4. The remainder of the solution parallels the substitution method. Now that we know the value of x, we can determine the value of y by substituting negative 4 into any equation that contains both an x and a y. Let's use 6y is equal to 8 minus 7x. Substitute negative 4 for x. Negative 7 times negative 4 equals 28. This simplifies to 6y equals 36. Divide both sides of the equation by 6 to isolate y. The value of y is 6. The solution to this system is x equals negative 4 and y equals 6. We can also express the solution as the ordered pair negative 4, 6. Finally, let's verify the solution. The left side of the first equation is 2x. Substitute negative 4 for x. This evaluates to negative 8. The right side of the first equation is 5y minus 38. Substitute 6 for y. This evaluates to negative 8. The left side is equal to the right side, so the solution works for the first equation. The left side of the second equation is 6y. Substitute 6 for y. This evaluates to 36. The right side of the second equation is 8 minus 7x. Substitute negative 4 for x. This evaluates to 36. The left side is equal to the right side, so the solution works for the second equation too. The values x equals negative 4 and y equals 6 satisfy both equations, so they are a solution to the system.